Okay, so welcome to this panel session. So I'm kind of just the organizer guy here. They're going to do all the smart stuff. There's a couple of things, a couple of rules. The first rule is it's a panel session. You guys get to ask lots of questions, so ask questions. Please ask questions. Pay attention. Think of questions. Ask questions. It's important. The second thing is these guys are going to get 4 minutes each to speak on the topic of their choice. No more, and I will start flashing fingers at them when that happens. That's my only other job. So we did actually come up with a list of questions in an attempt to make sure that everybody didn't say the same thing over and over again. We came up with a list of questions for these guys, and we're going to do it in what we thought was the logical order. Poor old Millap is feeling a bit sick today, so Tom jumped into the gap and is going to start first. I'm going to just briefly introduce him first. Tom Novlan. He's a principal member of technical staff with Advanced Wireless Technologies Group at AT&T. And so he's going to kick us off with an operator view of Open RAN.
Thank you, Alan. So, I'm, unfortunately, Millap could not be here today, but I'm very privileged to step into this place and represent the Advanced Wireless Technology Group based here in Austin, Texas. And I'm also a UT Austin alum, so it's extra special to be here at this forum. I really want to talk about how we see the evolution of O-RAN going into 6G. So this is a kind of broad question. There's lots of different layers, ways you can approach it, because 5G and O-RAN and 6G are all different things, fundamentally. They have different roles to play, but there's a lot of overlap, obviously. And so, and also because 6G is still at the very early formation phase, a lot of things that we are thinking about today are a bit speculative, but I think we see the broad directions where we can go in terms of the capabilities and then the implications on the network architecture. So when we think about the vision for 6G, a lot of these things are similar to things that we have put in place for 5G or what we wanted to put in place for 5G in terms of the broad goals. But there's also some new things and then maybe some even more bold directions that we'd like to take. So one thing we want to think about is that, especially looking at some of the use cases and applications for 6G, is really going to be extremely data-driven, extremely connected. We already have that with our networks today, but thinking about integrating the user data even more into the network, providing services deeply embedded in the network, which means we have to think very seriously about building a network that is secure and trustworthy. So building that from the beginning. So that implies the security aspects, the resiliency aspects, how to make it reliable. And I think some of the discussion here will focus on that. Efficiency is another important aspect. At least in my experience, I think a lot of the initial technology looks at the spectral efficiency, maybe looks at some of the capabilities. Energy efficiency is always mentioned, but it's not necessarily the first thing we do in terms of optimization. I think for 6G, we may have to take a different step, and maybe even begin with energy efficiency as one of the, or if not the most important KPIs from a network perspective, especially if we want to deploy this broadly and have it be a net good for the world in terms of green goals. Another aspect is the intelligence. So I think there's been a lot of discussion about how AI and machine learning will have a huge role to play. So I think we can see that this will touch every part of the network, from the physical layer all the way to the applications and services. Flexibility is very important. 5G has a lot of flexibility built in, but I think we'll see that even more brought from the upper layers, where we've really brought in some of these IT data center type concepts, which allow scalability and flexible deployment of resources. We're starting to see that a little bit in the RAN, but I think these trends will continue and we'll see it expand on a massive scale. But one aspect of that is flexibility, is that it requires openness. Because if the flexibility is there, but the ability for different network functions or different hardware to interact with each other is hidden behind proprietary interfaces, it's very challenging to get it actually to work. And then the last thing is service-centric. So in this case, the idea of having services on top of the network is something that 5G really focused on, slicing, thinking about providing end-to-end service. However, one thing that we see now for 6G is talking about providing services embedded in the RAN. For sensing, for example, is a service where the network itself is providing this capability. And so we need to think a little bit about how, from an architecture and interface perspective, we're not only thinking about the KPIs on the communication side, but what are the KPIs from a service end-to-end optimization perspective? O-RAN, I think, really aligns with this. So open everything, right? A front haul, transport hardware. The goal is to allow all these different functions, interfaces to work well together, and also adding intelligence. So we've seen many use cases leveraging this O-RAN framework, for example, smart traffic steering, the ability to do RAN slicing, your management and orchestration across the entire stack, and even at the physical layer, optimizing those parameters. So O-RAN already has those kind of tools that we think we will need for 6G. The question is, how will they be applied? One key area where we think this will happen is with the software and architecture evolution. So we go from already moving the functionality to disaggregating it. I think that will continue now even into the RAN. So the ability to distribute the resources, the ability to move parts of the protocol stack will definitely continue. So I know I'm running out of time. I don't think I need to discuss the details of the architecture, but just keep in mind that it will have to evolve. O-RAN was built on 5G, but 6G may not look like 5G, so how will that change? And then the last thing I want to think about is 6G will be a platform. So not just communications, but services. So O-RAN has the opportunity to think deeply about how we're also not helping the network be optimized, but how we're optimizing the services all the way from the core to the physical layer. So I think that is the end of my presentation. Thank you very much.
I'll keep going. There we go. Lovely. So in my excitement to get started, I didn't actually ask you your question, I don't think, but you answered it anyway. So I'll try and do that right this time. So Chris is up next. Chris Dick is Chief DSP Architecture. He's now at NVIDIA, and I have written down he's DSP Architect at Xilinx here, so I don't know why I took the old thing. He used to be at Xilinx for many years. Chris has been around for many years, and as far as I'm concerned, is like almost the software-defined radio go-to guy. So the question we're asking him, therefore, is what role will machine learning have in beyond 5G and 6G, and how is it enabled by O-RAN? And if 6G is AI ML learned, what gets standardized?
Great, thanks, Helen. Thank you for the Xilinx introduction. Do I have a slide? Okay. Actually, a preamble on when people talk about O-RAN, right, and opening up the supply chain, right, and extending the ecosystem. NVIDIA is one of the beneficiaries of that, right? And with O-RAN, disaggregation, RICs, right, programmable control, virtualization, and open interfaces. These are kind of the things that let NVIDIA platform come into the wireless space, right? And just simple things in a way, like opening up and defining the frontal interface. Let us bring the GPU into the DU, because when I talk about NVIDIA in the wireless space, it's not just that machine learning part, right? It's literally in the DU, doing the signal processing for the physical layer and GPU acceleration of layer 2. It has also enabled us to build an experimental testbed that we're very eager to bring to university and industrial research labs for being able to do data collection, right? To put into the hands of people capability to do first-class data capture in a principled and disciplined way. So in this figure here, if you can kind of read all the arrows, right? What we're showing is a project that we have that is enabled by O-RAN. We're capturing data from O1, A1, and E2 interfaces into a large-scale database in the cloud or on-prem, so think petascale type or petabyte type databases. And one part of this is around real-time closed-loop control, right? So for being able to bring telemetry data back, process it, put it into a database, bring it back around to RICs in the ORAN system or take it offline for further research. Anyway, so there's some of the important things that ORAN meant to NVIDIA, right? And how it let NVIDIA come into this space. I'm going to skip over a couple. Aha. Okay. So in terms of machine learning and AI in wireless, we kind of heard a lot of that today, right? So what I wanted to do is, one, I kind of picked the lens by which to look through this is 3GPP, right? In fact, today, there's the RAN1 working group on release 18, and that has already was commented, the study items of CSI compression, localization, and millimeter wave beam control. One of the things that we think is interesting, and if you look at the number of submissions of TDocs to 3GPP, kind of can't see it here, is a couple of other bits. So here's what's going on literally starting yesterday at 3GPP. The study items on use cases, so the beam management problem, the CSI feedback prediction and localization, but an equally, maybe even more important part around the collaboration model between G-Node B and the handsets, and how the machine learning gets factored between the ends of the link, right? Where does the machine learning happen? Where does the data capture happen? Where does the model training happen, right? So these, if you look through the 3GPP TDoc submissions, there's a ton of submissions on people trying to control how the system will be designed, where will be the machine learning, what will be positioned where. So I think those are interesting ones. In other areas, kind of not part of 3GPP, but I was kind of find this one exciting, the whole notion of being able to conflate various functional elements in the signal processing chain, right, and be able to solve them as a neural network here, kind of not quite show it in an end-to-end way, but to earlier speaker today, actually from Qualcomm, right, the notion of being able to build bespoke modulation schemes that may be site-specific, maybe time-specific, for particular realizations of implementations. I'm watching the clock too. The other things that I think are potentially interesting are when you think at like planetary scale digital twins, right? So we're very interested in huge scale simulations, but not just simulations, being able to bring planetary scale digital twins to bear. And then you kind of have a different scale of machine learning problem. And there's been some fascinating advancements, many people in this room might know, with the applications of bringing physics into the problem, right? So you kind of get an inductive bias brought into the machine learning model, and you can form, I don't know, almost miracles, right? Where this animation's gone, but okay, on the left there, it was literally a simulation of something we call Earth 2, which was solving Navier-Stokes equations, but for the whole of the planet. Some of these things, if you think about it, could be relevant in how you're going to model environments in digital twins. Todd had my second one here. If you're also into digital twins, you might be interested in mapping and how you can automate the introduction of an environment into the digital world. So the second one here was the use of neural radiance fields for being able to take kind of subsample data and build intricate 3D models. What gets standardized is the minimum. So here I kind of took one of the TDocs and I'm like, oh, this captures it pretty well. What's going on now? You'd need at least some standardization around lifecycle management, collaboration between the UE and the eNode B, right? If you're going to bring machine learning into the picture. Data sets, right? We heard about data sets yesterday. We heard a little bit about data sets today, but data sets for training, validation, testing, and inferencing, and setting baselines in 3GPP for doing fair comparisons over is machine learning better than model-based design, right? Because you can kind of get all sorts of interesting results if you search on archive. And then lastly, there's no shortage of standards people that are involved around the world at all levels for standardization. And what else could happen? Maybe 3GPP just defined the bounding box where the system designs the waveform and protocol at runtime. And then you just have to be careful about not getting into a Skynet situation with Arnold Schwarzenegger.
All right, thank you, Chris. That was great. Next up, we have Ian Wong. And I've got my intro here. That was the only thing I didn't have. Ian, excuse me a second, so I don't get you wrong. So Ian's, he's been in the wireless field for over 20 years. He's currently RF and wireless architecture in the CTO office at VIAVI Solutions. And he's also currently co-chair of the Test and Integration Focus Group in the ORAN Alliance, formerly for quite a few years where we all know him at National Instruments. And he's led the development real-time end-to-end 5G wireless test and prototyping systems for many years now, actually. So the question we had for him was basically massive MIMO, which is a particular interest of Ian's. If it's written in TensorFlow, how does that going to work, basically? So go for it.
Yeah, I'll try to answer your question. But yeah, kind of maybe a lot of you are not familiar with VIAVI. We're a test and measurement company focused really on anything network related, so wireless, wired. My personal role is basically all things RF and wireless for the CTO office at VIAVI, and my day job is actually attending the ORAN Alliance meetings, which are really exciting every morning at 8 a.m. throughout the week. So if any of you are interested, feel free to contact me. It's a wonderful job. Anyway, that being said, I do want to throw in as many buzzwords as I can in my talk, just so that you'll be interested. So AI/ML, massive MIMO, Open RAN. I got your attention, right? Okay. So basically, a lot of you, the good thing is I follow two great presentations talking about ORAN and the architecture. I'm not going to go too much into detail, but really I wanted to focus on what is Open RAN today, ORAN Alliance doing today for massive MIMO optimization. I think we've heard a lot about the impact of AI/ML for 5G today, primarily for network optimization. I think that's been the primary focus of ORAN Alliance, also in the area of massive MIMO, right? Basically, at the end of the day, operators like AT&T, they want to configure a massive MIMO system in the most optimal fashion possible. They spend billions of dollars in the spectrum. They want to deploy as few base stations as possible to cover as many people as possible, as cheaply as possible, right? So at the end of the day, that's the optimization. So policies, configuration, using machine learning techniques, learning about patterns and trends that are either in a small time scale or even up to days or weeks types of time scales, right? So that they can, intelligently allocate the right resources to the right users at the right time. Again, then they improve cell and user-centric capacity. Beam configurations is a big deal, especially for FR2, also in some sense FR1. Multi-cell, potentially multi-vendor. Now you're talking about multiple vendors coming together. How do I enforce these policies across potentially multiple RUs and DU vendors, right? And again, non-real-time and near real-time cases are all being considered in ORAN today. So looking at the ORAN architecture, there's the concept of real-time control loops at the ODU. This is where, primarily think of it as the MAC scheduler. That's where that resides. It controls multiple massive MIMO ORUs, right, via an open interface called the Open Front Hall. And here, the control loop is really fast. It's done at the TTI level. So the focus here is to use concepts called the RIC, RAN intelligence controllers, either near real time, which is in the time scale of 10 milliseconds in 1 second, right? Or non-real time, which again, greater than 1 second. We're talking about days or potentially weeks. And learning the environment so that intelligently allocate the beam patterns, the beam widths across the different cell sites across my whole network in an intelligent fashion. And ORAN is very focused on standardizing these open interfaces like E2, which is near real-time RIC controlling the ODUs and OCUs, and the A1, which is the non-real-time RIC, providing the policies down to the near real-time RIC. So that's essentially a nutshell of what massive MIMO optimization in ORAN Alliance looks like, right? So this is kind of where we are today. And some of the use cases that are being discussed and actually already in the first version of the TR can be kind of categorized into layer 3 mobility, right? A grid of beams, right? CSI, SSB and CSI-RS types of massive MIMO, right? How do I, again, shape the beams, the right beam patterns, the right number of beams? How do I do mobility kind of decisions, moving from one cell to another? L1, L2 beam management, a bit faster time scale. And then non-grid of beams, which is the TDD reciprocity, the true massive MIMO using SRS. That's the fastest time scale. That's also being considered in this TR. And finally, things related to massive MIMO optimization, like power, MU MIMO pairing, and MIMO mode selection. These are all kind of being considered in the ORAN Alliance today. So just to give you a flavor of how this looks like in the ORAN architecture, kind of drew a kind of a story, right? Like what happens here is in ODU, it will report the user activity, traffic load, coverage, per beam area, beam info, reach, all this data, gets reported, and the OCU, right, which is kind of where the PDCP and kind of aggregating multiple ODUs together, the QoS performance, the handover, the beam statistics, these are all reported up to what is called the SMO, right, the Service Management Orchestration. It collects all these configurations. It collects the KPIs potentially from the applied by the operator, and all these measurement reports that comes up from multiple ODUs and OCUs. And again, there's this concept of the non-real-time RIC, which is the intelligence, the brains of the operation, let's say. And that's really where most of the work happens, right? This is where they retrieve the configs, the KPIs, the measurement reports, and then uses this to train the models, right? And performance monitoring, monitor the performance, use the location of the UEs as another piece of information to really optimize the beamforming optimization. And then you monitor, and then you check whether there are issues, and you kind of potentially make changes and do fault management and so on. So finally, the SMO transfer that down to potentially the ORUs, and then the ODUs applies these configurations over the open front haul, and now eventually all the ORUs get it, right? So the reason I talk about this story is you can see, like there's a lot to be desired from a efficiency standpoint for 6G, and I think that's kind of the food for thought here for 6G, which is what I'm going to talk a little bit about, right? When you move from 5G to 6G for Open RAN and Massive MIMO, what are the things? First of all, we have heard a lot of great talks today about how the air interface is going to evolve, right? And obviously, that needs to be taken care of in the Open RAN architecture, right? Release 18, as we know, is already studying AI and ML for the air interface. You can see all the AI ML study items and work items for Release 18. Again, the support, and we've heard about this said multiple times, CSI feedback enhancement, beam management, which is a key component of Massive MIMO, and positioning accuracy, right? So 6G, really, we're moving now from just purely augmentation in Release 18 to potentially being AI native from the start. And I think that's kind of what we would expect, right? And finally, I want to kind of talk about this concept of zero-touch, fully autonomous cloud-based networks. I think that's kind of I would say, the holy grail for a lot of operators, right? So you want to use machine learning to really understand how to best optimize the network and not really have the human in the loop, because the humans, they're good. Of course, there's domain knowledge, and today there's network engineers whose job is to maintain several sites and kind of maybe assign the right parameters. And we want to kind of remove the human out of the loop in there and push them towards maybe more about training the right ML models so that the machine, the autonomous network, can kind of optimize itself. Kind of like, let's call it SON on steroids, right? And that's really where we're moving. And then again, 6G will move that to be a lot more native. Again, at the end of the day, as you can see, there's different timescales for optimization, and we expect all those timescales to be, let's say, smoothly operated in this Open RAN architecture. And again, kind of a plug to Chris's vision, and I kind of fully buy the digital twin concept, right? Like, in order for operators to really trust these AI/ML algorithms, they need to be able to really test and replicate that entire network in their lab and have a closed loop fashion of maybe deploy some models, understand the faults, come back to the digital twin, and then further refine a lot of these models for 6G. So with that, I didn't get a sign from you, Alan, so it looks like I should be on time.
So there we go, and we're up. So the next speaker up is Udayan Mukherjee. He is an Intel fellow and the chief technologist for networking infrastructure at Intel Corporation, and the go-to guy for all things ORAN at Intel, technically, certainly. I want to say one more thing about him, because when I looked at his bio, of course, for this thing, and I learned that he was also the go-to guy for advanced TCA back in the day.
That shows my age. Yes.
It shows your age. It shows my age too, that I know where that is. But I think that's super impressive.
Back,
so
early 2000s.
he's been automating and making boxes for many years now. So
yep. So Open RAN and then march towards 6G. So I wanted to get a clear understanding of, even before ORAN, we started this journey with XRAN. I think Brian talked about it. I was a founding member in the XRAN with a lot of other, with Verizon, Sachin, Stanford, and others. So the whole idea here is essentially thinking about disaggregation, look into the disaggregation at different layers. And this will give you why this is good for not only for Intel, for any silicon vendors. So this traditionally used to be a closed box, okay? And 3GPP standard defines interfaces on core networks and the UEs and others, but this used to be a closed box. What ORAN tried to do, and I'm still going through that process, is disaggregation. Disaggregation in many different ways. Radio disaggregation, you can see the radio, the radio you need, the open front hall interface. The compute disaggregation, control plane disaggregation, the rake, you heard about the rake which ORAN introduced. Management plane disaggregation, and then last but not the least is the fully virtualized hardware and software disaggregation. And you will see how this will actually map to some of the tenets of 6G that we are talking about. So what does it do then? Why bother about this? So this actually created agile RAN. Network built on the old static, purpose-built solutions were not flexible. Okay, if time permit, the fourth slide, I'll show you a platform that we are designing today and how the cloud, hyperscaler taking advantage of it with the data that is exposing. And you can build, the community can build a lot of applications on top of it. And then programmability, observability, you see how this maps to security. It's a closed market, used to be relatively closed, only a few handful of main vendors. Now that creates limited supply chain. And again, another tenets of 6G is actually that expanding on that. Closed interface, security, resiliency is how much you trust that single vendor, okay? And then limited innovation. Now, this is the eye chart, but what I wanted to do here is take a next G6 audacious goal for 6G and just try to map. I'll not go through all 6, probably touch 4 of them. But you can sense that, when we talk about first and foremost trust, resiliency, and the security, the open interfaces, open platform, always brings a whole observability stuff that you can expose the data. You can see what is happening, and a community can contribute to it. That's actually a march towards that open platform, more secure systems, and expanding supply chain on this so that there are a lot more vendors from silicon, systems. Alan in yesterday's talk talked about that not too many North American vendors for the machine, the infrastructure we build, base stations, packet core, there are packet cores, but base station RAN. We are going to build more and more of this. I spend my time, in sometimes in Washington, D.C. with some of the U.S. commerce, agencies, and it's always been prodded around. Where is this RAN coming from? The U.S. manufacturers, North American manufacturers. So this is an attempt towards that you open up that innovation, open up that supply chain. And I'll skip digital world experience and cost-effective solution. You can actually map those and see how an open platform can actually enable that. But distributed cloud and communication system, I'll tell you the conjecture I'll make that ORAN made it happen. The virtualized platform is the march towards the cloud native platform. We are already deploying 5G system, not that as a virtualized system, but in ports and containers in North America as well as in Japan and in Europe as well. And then this AI native wireless network. A lot of people talked about that. There are 2 examples here. We are in Intel Lab. There are folks here. We are researching on some of the machine learning in the actual, the air interface side of it, especially in the channel estimation and other areas in beamforming. Those are examples. But the newer AI ML applications that is actually can be built on the data that you are exposing through RIC is, it's a new value add. And the sustainability, this innovation in energy efficient platform. Cloud has been taking advantage of that. If you look at the Intel multi-core CPU, there are C state, P state, multiple different way of actually saving the, the power. There is a actual demonstration that Deutsche Telekom did in MWC. You just Google it, talks about that at any given time in a 24-hour period, what actually is the power consumption as opposed to the power rating. So you'll see, I mean, it's eye-opener. So all of these are actually made available because of this. And last but not the least, I leave this thing to you. Open platform, and this is the only thing with the Intel plug, an open platform that we did with FlexRAN and exposing a hyperscaler in North America to actually take the data, not only from the rig, but directly from the platform for layer one, channel estimation data, all the IQ data, and creating a lot of, and connecting that with that Power BI, business intelligence, and Spark database to actually create a lot of applications on top of it. Imagine that in 6 you will expand that. Thank you.
Okay, thank you. So last, and everyone's staying pretty much to time, is Venki Ramaswamy. He's Chief Technologist at MITRE Labs and leads the technical innovation and R&D activities in 5G and XG technologies. And the question we asked is, how will 6G achieve the ATIS NextG Alliance goals of improved resiliency? So.
Hello, everybody. And first of all, thank you so much for inviting me to this forum. So I want to start with something that Charlie mentioned today morning about all the activities that are happening in the world relating to 6G and setting visions and so on. And one of the alliances / groups that we are interested in is the NextG Alliance. So NextG Alliance, I don't know how many of you know about this. It's a group under ATIS. ATIS is a standards development organization that partner with 3GPP. So ATIS has several groups that are working to set the vision for 6G and to drive US leadership in 6G and beyond. And one of the working groups that they are focused on is the roadmap working group. Amitabh here is the leader. He's chief there. And they have actually defined 6 audacious goals for 6G. You can see all of them there. But today I'm going to just focus on the first one, which is the resiliency, trust, and security. Security, we all know what that means. Can you hear me? Yeah, thank you. So security, we all know what that means. Trust, in my opinion, is mainly the reliability of the network. How reliable is the network? Can you really expect the network to provide the kind of services that you need? Because if you are really dealing with some sort of a mission critical service, and if the network cannot provide the kind of service that you are expecting, then it's really not useful to the operator or anyone who is using the network, right? So that's really the kind of the trust that we are expecting. More importantly, it's the resiliency. And this is an aspect that everybody wants to talk about. Everybody wants resiliency, but nobody has really taken the time to define it. Because if you don't define the aspect of resiliency, if you're not able to really quantify it and measure it, there is no way you can improve it or manage it, right? So the most important thing, in my opinion, is that the definition, the metrics that are associated with resiliency is missing in all the standardization activities. And that's kind of the frustration that I have and most of the people that work with me have. So let's look at what resiliency means, right? It is the ability of the system to really anticipate, withstand, recover, and evolve from any sort of stressor. So what is a stressor? It could be a failure, it could be an error, it could be any sort of changes in your environment, natural disasters, for example. So the picture there actually shows a little bit of what I mean. Let's say that you have a system that is actually operating under normal conditions, and it has some sort of a performance that it is expected to deliver. At some point, it is given a stressor, so you can see that, and the expectation is that the performance is going to go down. But the most important aspect is that when the performance goes down, the system is able to recover and rebound from that stressor. So you are able to rebound from all the degradation that you're expecting. And also, the important aspect there is that you are able to do that in a very reasonable time, and you are also able to do to get back to a performance that is acceptable. Now, IMT 2020, which is really defining the minimum performance requirements for many of these new next-G systems. So IMT 2020 is the one that defined 5G, and IMT 2030 is the one that will define for 6G. They have minimum technical performance requirement for reliability. They say that the probability of error cannot be more than 10 to the minus 5. That is a target value, but in my opinion, that's very, very restrictive, too narrow in scope, because they don't talk about the kind of resiliency that we are after. Now, we have done a lot of work in the area of resiliency, and we feel that there are a couple of different characteristics of a network that will give you the kind of resiliency that you're after. One is the fact that you are able to really anticipate. You are able to have situational awareness. Sorry, it's of the network, and so that means that you are able to really understand and scope out what is really happening in the whole network. So that's what we call as a full stack observability and learning. The second is, even if you understand that something is happening, and if you don't react to it, it's not really going to help you. So that's the adaptability part. So you need to be aware of what's happening, you need to anticipate what is happening, but you also need to really react to the stressor. The third part is the stressor itself, right? One of the most important, or the most kind of stressor, is a human error itself. And the reason for that is because the network is so complex. Complexity is causing all these errors. So if you're able to really abstract out, which is basically happening in the form of control plane, data plane, and management abstraction, and use automation to inculcate some sort of a simplicity, that's going to really improve the whole performance. So with awareness, with adaptability and abstraction, you are really looking at improving the resiliency. Now, if you look at the observability and learning, open interfaces is really the key for those. Adaptability, on the other hand, will come through softwareization, virtualization, and also programming, right? So if you make the networks more and more programmable, you are looking at more and more adaptability. Open interfaces, most people may not think as directly related to programmability, but most of the programmable systems are also having open interfaces. So there's a connection there as well. Now, the last part is the data plane, control plane, and managed plane abstraction and separation. And that will lead to automation and more intelligent control and things like that. So all those things are really part of the open architectures, and the open architectures are the ones that are leading to the three aspects that I was talking about. With that, I think I am out of time. I do have one more slide that will talk about some of the questions and things like that, but we will leave it that to later. Thanks.
Okay, they pretty much kept it time. If you want to applaud them one more time for that valiant effort. Panel session that kept to their 5 minutes. It's fabulous. So now we're going to get to the question and answer part of it. So I hope I'm not going to say very much of anything, and you're going to put your hands up, and I'm going to point at you, and people are going to run up and down. So that's how it's going to work. So do we have any questions? Yes, we do. Excellent.
So I'd like to ask a question on behalf of all the current PhD students and future PhD students. So I'm not super familiar with ORAN. I learned everything I know just in the past 30 minutes or so about it. But how would you, or what advice would you give to PhD students or academics that want to conduct research in this area? Because at least from my naive perspective, it kind of seems to more affect industry folks. Are there ways that we can conduct research that better prepares for this ORAN versus previous architectures?
Hello? Maybe I can take that. So I think there's definitely a lot of problems that are really suitable for academics to really help out. I mean, that's why there's the industry affiliate program. We're bringing problems to your professors as we speak. Things related to the RIC, AI and ML for network optimization, AI ML for obviously the air interface. How does that evolve? How do you evolve the open front haul, for example, when the air interface itself might change, right, through AI? And optimization of the network of the RIC. These are all things that we need, really bright PhD students to help us figure out. So, I mean, at least from my perspective, there's a lot of rich problems here, especially on the RIC side for academics to really help out with.
Yeah, so I don't know how many of you know this. The real origins of Open RAN came from a Bell Labs paper in 2012, I believe. And that was talking about more how can you split the functionalities of what is the optimum split that you can have for the base station, right? So that paper itself is coming from very, very analytical people, and not from the industry, even though you call it as Bell Labs as an industry, it's actually people who are deeply ingrained in all the analytical problems. So I have a set of questions that I was talking about before. There is all sorts of optimization problems that you can think of when you're doing this Open RAN. Just the instance of ORAN itself is more industry related, but to get to that level, I think we need to answer a lot more questions that will finally become standardized and things like that. So I do believe that you have a lot more role as students, especially students from UT Austin with deep wireless expertise. I think this is an area where you can contribute a lot.
Yes, Udayan. Yeah, from a hardware perspective.
Just to add to that, not only Bell Labs, but if you look at XRAN, I mean, the folks like Sachin Katti, who was a professor at that time in Stanford, was the guy that got involved into the XRAN. So this open, think of it that way, that what can you do, create fault isolations, it's a virtualized world right now. It's a container-based world. How do we actually do, more resilient and secure systems? When you have a system with all the IQ data in your hand, or you can get into it, what can you do? What kind of location service you can build on it? Next set of startup companies can be built, not just on focusing on machine learning on the channel estimation. That's a problem, obviously, we need to address, but also the data that this open platform exposes to you, what kind of services you built on it. So think of it that way. RIC is one example, but you can actually probe directly to a platform. That's what an open platform gives you. So I think, I mean, we are just scratching the surface here. So.
Yeah, even the control applications that Ian was talking about, right? So think of situations where you have multiple control applications. How do you do efficient conflict resolution, right? I mean, that's a very difficult problem. People may not think about it, but it's a very, very difficult problem. And to do that in a very verifiable form, it's not something that folks from the industry can devote a lot of time. So we definitely need help from you guys, for sure.
So Chris, as well, from an architecture, I think maybe for Udayan too, because I was hoping Udayan would say something about architecture as well.
Yeah.
But maybe, because I don't know, he could be a computer architecture student, I have no idea. But there's definitely a question there, right? So maybe Chris first.
My comment, right?
Yeah.
And I guess it's kind of an applied research thing, right? You were saying, hey, it kind of looks like this stuff's only useful if you're building a network. What's the research angle, right? So with an applied research perspective, I still think it's interesting around, I would claim there's not a lot of publicly available information that characterize the performance of model training on the RAP infrastructure, on the XApp infrastructure. Because I guess what no one mentioned today is this kind of timescales by which these, the non-real-time RIC and the real-time RIC work. All right, so non-real-time RIC greater than a second. Real-time RIC, 10 milliseconds to 1 second. And then people, even in academia, are proposing, there should be DApps for real-time work, right? And so one of the, I think it's interesting, problems is by the time you put all the software infrastructure in place to be able to support this openness, right, what are the implications for overhead? What sort of problems can you address at these time scales of less than 10 milliseconds, 10 milliseconds a second, greater than a second? And then, I guess, contrary to the Microsoft presentation this morning, maybe what are small neural networks that one can cleverly craft so that you can be doing, rapid, real-time, fast online training, say in the distributed unit, right, the DU that was up here. So I think there's a lot of kind of applied, interesting applied research problems.
Yeah. Tom, do you have an operator view?
Yeah, I think one thing that's, right now there's a lot of focus on taking the existing 5G architecture, putting the O-RAN capabilities on top of it and optimizing. I think from a research perspective, when we look at 6G, since it's so early, knowing that we will have these capabilities to move the resources in different places of the network than we've ever done before, knowing that the ability to have information about user context from the device, from the application point of view, deeply embedded inside the RAN in the way that could actually be computationally possible will be there. What is the right way to design an architecture? What is the right way to design the network? Will 5G architecture evolve into 6G? Maybe some aspects, but there might be some very transformative and very disruptive things that you can do, knowing that now where you place the data, where you place the AML is very, very flexible. And so we can rethink a lot of things that maybe we've kind of assumed because we had this kind of monolithic hierarchical architecture that 5G still has in some ways.
Okay, right behind you. Oh, he's got it. You're good.
Yeah. So I just wanted to add one comment to the question before, and then I want to ask one question of my own. So coming back to the whole point about Open RAN is to allow multiple people to contribute. And the whole idea is you don't have to develop something end to end. So if you come up with an idea, you can actually just focus on that problem, innovate, and push it back into the whole ecosystem, and everybody can make use of it. And that actually allows for a lot of innovation, which was not there in the past. So all researchers and people, I mean, if you can come up with an excellent idea, it allows you to come up with a startup, I mean, build your technology, execute it, and push it into something without having to build complete end-to-end closed solutions, which was what was stifling innovation in the past. So I just wanted to address that point. The question that I have is more from, I mean, we discussed Open RAN and 6G. The question I have is, if you look at the way standards have evolved, I mean, from 2G, 3G, 4G, I mean, they have been typically very prescriptive in the sense, how do you do your modulation? How do you send your reference signals? How do you do channel coding, for example? And we discussed all that today. But one question I have personally is, as we go towards 6G, where we have this AI, ML, and all these techniques coming, where everything goes in the sense, I mean, as long as you may come up with a new algorithm, new design, I mean, the standards may not have to preclude it because everything is being done in an intelligent, adaptive manner. So the question is, do we need to rethink the way we do standards to allow these kind of AI, ML kind of designs where there is no hard and fast rules for designing networks? It's all based on some intelligence that it automatically finds and figures out what needs to be communicated between a device and a base station.
So maybe that's a great question. I think maybe if in the spirit of this session, it's kind of like, what's the relationship of O-RAN to 3GPP, I think is kind of what you're asking, because the example, I said that they're practicing Kung Fu upstairs, apparently, I have to apologize. But what's the relationship in the way that 3GPP is what you described when you said they prescribe exactly how it worked? I think maybe we could even talk about, is O-RAN too prescriptive today as well, perhaps, and how is O-RAN going to change, and what part of that will then allow it to kind of take over or nullify some of these issues in 3GPP, I think is what he's asking.
Well,
so, yeah.
Maybe just as someone who's lived both 3GPP and O-RAN right now, I would love to see us change how it's done. And I've actually read a paper about AI being able to replace the hundreds or thousands of delegates that are going to 3GPP meetings one day, and maybe 6G is the last standard we standardize. So I personally think that's probably not going to happen, but you know, think about it, right? If we replace everything with a neural network and just learn the environment, then maybe, you know, we don't need to standardize it so strictly. But you know, I think that's still pretty far away. I mean, I would say, you know, there's a benefit to standardization. It's, again, like we talked about, you know, economies of scale. I think that will still need to be there. But I think there is going to be different things that will be standardized, right? Like maybe instead of the exact, you know, as Charlie kind of mentioned, right? Like 5G kind of swung really on the other side of flexibility, and you expose all these tons of parameters that can tweak every single thing about your Phi and Mac, but maybe AI/ML native air interface allows you to standardize just the basic data that needs to be kind of acquired and the control that actually goes back down to your neural network. And so I think there's definitely some potential trajectory towards there, and I think, you know, one thing about ORAN and 3GPP in the spirit of this panel is, as you all know, of course, 3GPP came out before really ORAN kind of started coming up, and so it's kind of has forced to coexist. And as you all know, ORAN really is very much operator driven, right? Because it's really operators trying to, you know, wrestle control back of the ecosystem, somehow opening up the marketplace for more players. And I think 6G, we will see that there needs to be a much more harmonization between 3GPP and ORAN to kind of work together. I think, you know, it's not like it's competing against each other, but I think in 6G, it's kind of almost required to kind of approach this together, would be my take on it. Yeah.
So operators were mentioned, Tom, and if I could expand on that I think one of the great challenges is, to the original question, if you've got some crazy AI algorithm written by some third party popping into your network and doing some crazy thing, how comfortable are you with that?
I'm still dreaming of the day when my TDocs are written by an AI/ML algorithm instead.
That'd be great.
But what about your network, though?
So I think it's a very valuable point, and I think, you know, we see that, you know, bringing this framework of the cloud into the radio access network, we get some benefits, right, that were mentioned. We get the ability to have the benefits of virtualization. We also get the benefits, hopefully, of fast innovation. I think it was mentioned that, you know, 3GPP has these monolithic releases because you have to really make sure everything is kind of fitting together and working, and you kind of freeze it and then you build on top of that. But with software, there's the opportunity to do things much faster. So in some ways, you know, I do think the 6G standards process should evolve to be flexible and faster and not necessarily tied to releases in the same way. But there's also then, as you point out, a need that it needs to be stable, especially if it's going to be deployed at large scale. So then I think some of the aspects of like the digital twin idea of having an environment where we are able to prove out the algorithms under conditions that we think will really reflect what we see in the network will be important. I think also having a very good management or orchestration framework that understands where the algorithms are working, and you know, having fallback behaviors, having the resiliency, it becomes very important. And if you can have that as a framework, then I think you'll probably see areas where you might experiment in a specific setting to try out some algorithms, and then if that's successful, you can expand it to larger areas. But you do have to have a framework where you do have you know, common APIs, and I think an ability to test it offline is very interesting.
So go you get the mic right there. Oh, sorry, you already had one. You're next, but you're definitely next. I just wanted to say, you just answered the first question beautifully in terms of what should these students be studying, because you gave them a whole list of things that was a fabulous list of things that universities need to look at. But anyway. It takes a couple of seconds.
I have a question. As you go to 6G, you see that traffic demand will increase, so we'll have a densified network. So you will see more and more millimeter wave base stations, right? And how will ORAN adapt to that? Because the concept of DU and RU will go away. It will be all in one, right? How ORAN will evolve in a densified network?
Yeah, what about the splits? Did you get the splits wrong? He's asking.
It's actually funny. Even before the 3GPP NR, if some of you, you probably were there, I mean, we did the Verizon 5G TF specification. That specification was actually for millimeter wave, 20 gigahertz and 39 gigahertz. We thought that that will be the taking the lion's share. And we implemented O-RAN-based systems on that, and that was actually demoed in using actual mining companies doing a whole bunch of disaster recovery elements of systems. So I think systems can be built. The disaggregated systems doesn't mean that you cannot address millimeter wave and beyond. And it also is logical. It doesn't mean that this only have to be far off, the radio is somewhere else, Cloud RAN is in some centralized location. These are logical. You can put everything together. A lot of the cloud native network or vRAN that we are implementing right now is cell site because a lot more traffic is not coming. So it's a mix of it. So I don't see an issue here.
And I would say, like, really, if you want densification, you need to have IAB, right? I mean, it's really using the wireless. I mean, you've got all this capacity, use it for your backhaul. And I mean, does O-RAN need to standardize that? Maybe, maybe not. I don't know. I mean, right now it's actually standardized by 3GPP, right? So you're actually using the F1 interface over the air, and I think it's wonderful. We just kind of need to be smarter about. I mean, Release 18 is trying to be better, right, with smarter relays or mobile relays. Because again, like that's kind of the reason that millimeter wave didn't really, quote unquote, really fulfill the promise so far, right? It's got a lot of hype during 5G, but I think 6G will definitely need to kind of do better there.
Yeah, on your IAB question, so someone will manufacture the IAB nodes with empty functions in it. There is a business case for it?
Or did quite understand.
I think you're asking if we build pieces of hardware.
I mean to say that the IAB nodes has mobile function in it, but it is different from UEs, right? So, so again, like NTN, is there a business case for it?
So I take your question a little bit different direction because I think one of the challenges that we have thinking of 5G, we still have to think about these stacks. As when we designed IAB, you need to have that backhaul connectivity. So reusing the UE stack is very simple from a specification point of view. I think you're pointing out that from a business case or implementation perspective, there are challenges. So then I wonder, especially from an O-RAN perspective, maybe we also don't just look at the interfaces and try and make them efficient or open, but we also look at the stacks themselves. Are there parts of the UE stack that could have been removed for a backhaul use case, maybe for an NTN use case or a UE relay use case? You would need to have this backhaul link, but the stacks there are actually customized and optimized that helps make that trade-off better. I mean, that's another way O-RAN could actually get involved, is looking at customized stacks.
Yeah, one more.
Yeah, so 6G, I think they're talking a lot about hyper-specialized networks, right? So as Udayan was talking about, there are all these logical components that you can create and stitch together that will be very specific for a given applications and things like that. So you don't have to do a 7.2 split. You can do a split that is better for a given application, right? So it's the ability to move around these logical functions that will be best for a given application is what I think 6G is going to bring.
And that will be one of O-RAN's challenges,
right.
Perhaps. And which, by the way, I love your slide that we ended on, and I think that comes under the simplicity through abstraction and automation section.
Because if you cannot abstract, right, you are not getting the simplicity which is required. Because simplicity is the ultimate sophistication.
Okay, next question.
Okay, I think my question was related to the previous discussion. So we talked about the fact that open interfaces, disaggregated interfaces will expose all the data and you can do a lot more with it. But correspondingly, would it open up more security threats, attack surfaces, and the cost of securing an open network would defeat the cost effectiveness of that network? So would the panel comment on that aspect and what they're doing about it? Thanks.
Venki, maybe you're the security guy, perhaps.
I'm not the security guy,
You're
but I can.
the military guy. No, I keep calling him that, and he keeps saying he's not that, but he's the military guy, so I always assume he is.
a resilience guy, not a security
Brilliant,
guy.
sorry, there you go. Go ahead.
So that's a very good point. I mean, obviously, when you are opening up more interfaces, you are opening up more attack vectors. But there is nothing fundamentally that we cannot do to secure them, right? So for example, open front hall, you have the management plane, you have the user plane, control plane, synchronization plane, and other planes, right? So you have to use all sorts of latest security principles using PKI security to make sure that the different components are themselves authenticated, secured, and things like that. So yes, it is going to open up a lot more security or vulnerabilities and attack vectors, but we also have techniques to mitigate them.
So maybe we could get each of the panel just to say what the biggest security problem will be for ORAN and 6G and how to fix it, and just see if you guys can come up with one. Is there one thing that keeps you up at night? We won't start with Venki because he already answered it. So just let's go down the line. Udayan, what worries you?
Yeah, I mean, to a certain extent, what Nagin asked. I mean, open systems, interfaces, a lot of things. You know, turnkey, one vendor solution, one neck to choke, always it has some advantages that way. That you depend on this thing, you have been traditionally working on it. I mean, there's the old saying that, you know, nobody gets fired from buying from IBM. You know, there's like, you know, so I think you can trust that. Now, but similar, questions were raised even when you open up the operating system to Linux, you know. So a lot of questions, I remember the same kind of question being asked, you know, but the community, I mean, you get more and more eyes and development and energy and talent of the community to build on it. So yes, I've been open interfaces, exposing data creates more, potentially more areas of attack, but there'll be systems built.
More defenders as well as more attackers is your point, because it's an open system.
Yeah.
So what worries you, Ian?
I mean, as VIAVI, I mean, you know, the more problems there are, the better for us. So I don't lose any sleep at all. You know, we're a test and measurement company, so the more threats you feel, the more business we have. So. No, kidding aside, I think. Right? Yeah. No. I mean, I think, you know, for us, of course, we actually test a lot of security. In ORAN Alliance, there's a security focus group, right? It's actually over the last year and a half. You know, in ORAN, there's things called working groups. There's focus groups. Focus groups are kind of spans multiple work groups. But focus group, they started coming up with a ton of specifications. The workload is high again because, you know, just because it's open, right, doesn't mean it's insecure, right? I mean, kind of going back to the open source kind of analogy there. But that means there's a lot more work to be done, right? And so I think, you know, in fact, in ORAN Alliance, this is news probably for a lot of you. It's changing the security focus group to an actual security working group, right? That means it's actually going to be very rigorous about its specs, very rigorous about its test and core specs, and because again, I mean, it is an issue. It has been raised by different governments, and but again, like, you know, disaggregation, you know, security by obscurity is really not a good strategy, right? So actually opening it up, looking at it, more eyes is actually going to help, and I think that's, and again, opens up into the broader ecosystem to come up with better solutions. So,
Chris?
Yeah, I guess I'm not the security guy, but when if you look at many of these papers on digital twins, probably by far the majority of the use cases and applicability of digital twins to wireless end up more at network operation, management, configuration, and security, right? So one theory could be, right, NVIDIA theories, if you believe in like supercomputer scale digital twins, right, and you close the loop, and you truly have a true digital twin with a cyber rendering of the physical world, right? Now you can detect traffic anomalies. You can deploy software to 10,000 base stations in the digital twin before it goes to the physical world, right? So there's, can you do it? I don't know, I guess we'll see. But there could be one way, right? There's the...
Yeah. Tom, you're the one that's going to get sued at the end of the day. So.
Hopefully not me personally.
Not you personally.
Just the researcher, but I think the idea that we have this ability to provide services, which implies that the data is going to be living at the edge of the network, means that we will have software and applications running very close to the edge on this hardware, and that means, you know, patching the data, doing your security scans, antivirus, all this type of things you have in the cloud now moves into the RAN, and that's it's a very great opportunity, but it's a big challenge.
I'd like to add something as well, because I think there's another analogy as well, which is the difference between running applications in the cloud and running them locally. One of the reasons people store things in the cloud, run them in the cloud, is the idea, at least, that the cloud is this massive thing, and so its security is all up to date. And I think that with Open RAN, there's an opportunity to have the latest security all the time, as opposed to the security you had 5 years ago when you installed the equipment. So I think there is but that requires us to constantly improve and update the software on those systems out in the field, right? So so there is there's some reason to hope. I think, again, maybe the ORAN guys need to make sure that they focus on security. Maybe the biggest concern is they won't do that properly, but it's a massive issue for them, definitely. Okay, other questions? Oh, are we out of time? Jeff's saying, one more question? Okay, well, maybe, yes, Anthony at the back. Just when we thought Anthony wasn't going to ask a question, at last, Anthony's going to ask a question. It's fabulous. I feel like COVID is finally over when I'm sitting in a room and you're going to ask a question, Anthony. It makes me feel so good. Go for it.
It's been a while, Alan. You know,
I know.
we had this discussion, but I couldn't resist because I think you guys are really talking around the $600 gorilla, you know, that's sitting in the middle of the room here. You know, you're all talking about updating the security and so forth. But who's going to do this integration? Who's responsible? You know, how are you going to do this just the security part of the integration? You know, you now have stuff from all sorts of different vendors that are through this open source. You know, how do you guarantee that? You know, that there has to be some way of doing that.
Yeah,
a fair question.
So I think that's a good point, and I think if you look at other areas where we have platforms, I mean, we talk about ORAN, we have apps, right? I think they're called apps for a reason, because the idea is that the network is becoming a platform, and you know that some platforms are more open than others. Some platforms allow different types of applications, but there's always some fundamental rules that have to be there, and I think that will be a big role for ORAN, and then for the service providers, the platform providers themselves to define those boundaries and rules. And depending on the use case, they may be very strict, they may be very loose, but there will have to be some type of regulation along those lines if you're going to have a platform.
But look at it in today's world. In today's world, you're from AT&T. You come to me and cry to me when there's a security breach. And I'm the guy who's guaranteeing it. I'm the guy who's paying the penalty, right? There is somebody who's guaranteeing that security breach across all the different pieces that you have. Who's going to do that?
But isn't that how
is that going to get done?
Isn't that how the cloud works today, though, Anthony? I mean, this is not a new concept.
It is not a new concept. The question is now the onus shift from me to you.
So one thing we didn't talk about is the rising role of system integrators, right? SIs, which I think, I don't know if there's anybody in the room here represents that industry, but at the end of the day, if you think about it, you know, what is a major NEM today? It's a system integrator, right? It just so happens that the whole system comes from a single vendor. In some cases, actually, they have components that are from other vendors as well, but you know, kind of going back to the single neck to choke, I think system integrators will play a bigger role. Actually, in a way, operators are going to play a bigger role, right? Think about the open test integration centers in the ORAN Alliance. It's a huge emphasis on testing and bringing, PlugFest coming together, and it's obviously great for companies like mine and VIAVI, because you need all these test tools to make sure that every component kind of satisfies the standard. But yeah, I think SIs will play a big role, and operators themselves will play a big role, and so yeah, at the end of the day, maybe you'll have 3 or 4 necks to choke, but they're still necks to choke. Don't worry. Yeah.
Yes.
So I don't deal with all the commercial activities, but we do have private networks deployed, right? And the major aspect that I'm looking for is the complete control of the network rather than anything else. I don't mind if we have one operator or one vendor providing all the different components, like, for example, Nokia providing CU, DU, RU, as long as they give me the control, they give me the interfaces open, right? So that's what I'm looking for. I want complete control of my network to be able to bring in innovations that are that a third party who is very familiar with the domain that I'm operating in to inject control functions. So that's what I'm looking for. And there is no integrator role there because it's one operator who is doing it. And it's all open, and I have the ability to manage my network. I have complete control of that network. So that's the real value for us in having these open architectures.
Okay.
So in essence, you don't care about Open RAN.
We're at Anthony.
We care about open architectures. It doesn't matter whether you call it as Open RAN or ORAN or something else.
No, you care about a way to control your network. As
Yeah,
long as I provide you that.
Yes, I do control. I do want the control myself, not to give someone else.
So we're out of time. It's great. It's lovely that we couldn't stop this thing, and I had to step in and stop it. That's a great panel. So I'd like to thank these guys one more time.